Alright guys, it's William Jamming here. Previously we discussed about Google's Colab and I think it's great fun. And what I'm going to do is to use Google Colab to get all these nodes while we share and this knowledge. And I'm going to take all this note here so you guys won't need to take notes. And let's get started. For example, if you got this is previously printed out thing. If you want it is deleted, you just tab delete and it's deleted. Okay, so if you want to delete it, tab it, delete it. Welcome to Colab, delete it, and it's totally blank. Okay, and of course you can rename it notebook. This will be our the first chapter about machine learning. Intro. Okay, so let's add some text. First I would like to introduce you guys the sort of the flow of your processing approaching the machine learning. So first is that you need to get the data. So I think data is one of the most important thing that you need. It's like the strategic resources right now. You need to get the good data. We got a saying say the garbage in, garbage out. So you get a garbage data in, you got the garbage data out, and you got this garbage model trained. So yeah, and sometimes it's sort of a labor-intensive way of processing data to get data. Say you got this Google's car, because you know Google got a Google map and they got a car actually on the street and collecting all this data. You got this satellite flying above and actually collecting and taking photos and generate billions of gigabytes of data. And so it may be labor intensive or computational intensive. So once we got all sort of data, we need to pre-processing or processing that data. And first is the data section. The second is the modeling section. Okay, modeling section, and the third part will be the evaluation section. Okay, so once you got the data, so gathering data section or data processing section, you see. Okay, so I think mainly if you are dealing with the machine learning, it's just can be divided into three parts. Okay, so data processing will be you got our data. You can buy proprietary data. You can collect your data in your own way, and you can generate dummy data using algorithm. Okay, so you can use all sort of things, but just remember you need to get good data. Okay, good data is important. And this is one thing. The second thing is that because this is machine learning, not deep learning, and you need to treat your data with care. So for example, if say you generate you got a lot of data about a plane, and plane is fine, okay, and their engine is humming, is turning around, and you sort of generate a lot of data when the engine is running, and you may record all this sound while you fly. Okay, and that is data, but that's not good structured data. And for example, you got billions of people using Google Map or any of the mapping service or whatever service, or maybe Twitter, something like that. You get all this text info and geolocation info, the image info that people post on social media, and that is not structured data. Okay, so machine learning is a sort of learning I think can be classified as a sort of a classic and old school machine learning. So they are using the algorithm that have a pretty high standard requirement for your data, so you need most of the time structured data. Okay, so if you use this machine learning model, you will hire maybe assistants or assistant researchers to get your data, to clean this data, and to make the data usable by this algorithm. So yeah, and of course there's one important step we need to do, because I think a lot of the machine learning algorithm we need to do that is sort of a requirement, is to split the data. Okay, split the data, and we need to split the data into two sets. One is the training set, is the data that you use to train your model, and the other part will be the testing set. So that is the actual real live data that you need to test your model, whether your model is good or not. So you sort of need that testing data in order to evaluate your model. Okay, so and you can use the test data to test the say you got certain metric that can evaluate the performance of your model, whether it is a good model, bad model, whether you need to change another model completely. Okay, so you use this test data to test it out, because the test data is also the data that you gathered, and most probably is from the real world, so you can dealing with the real world scenario using this test data. So you need to split it, and sometimes we need to do multiple split. You split, you test, and you randomize this process and split and process and predict and evaluate again. So you might just jump around the step 1, step 3 all the time, and then you can get this sort of average model, or just adding weight. But that's a pretty complex process. We will discuss that in this in the future when we discuss the decision tree and random forest, something like that. Okay, so yeah, and the second is modeling. Modeling is just build model, train a model, and using model to make prediction. Okay, so pretty simple. Just you can treat modeling as a way of gathering info and conceptualize it, and just to make a conclusion about all this data. Okay, so if you got this say a linear model, we got a lot of dot here, and you got the best model, and that model will be say a certain line, and that line is a conceptual representation of what's going on with all this data. You gather all this data, and what does it mean? You need a pretty elegant and concise mathematical way to express that. So it's pretty much like you act as a human, and you conceptualize certain things. You experience a lot, and you make a certain concept out from all these things that you have experienced. So that's my personal opinion about it. Okay, so yeah, so essentially we need just select the model and train our model. Train our model, and yeah, using our model. So pretty simple. Using our model, of course, we use model to make predictions, to just to make sense about. You train our model. You build a certain model is to sort of using a conceptualized way to make sense of this whole world. And we use model to make predictions. It's like we get a generalized idea about what's going on, and we want to use that knowledge to predict what will happen in the future, so we can be better prepared. That's basically how humans survive in this pretty complex and ever-changing environment, because we're surrounded by things, and we need to let it all make sense. Okay, so yeah, then evaluate. As I said, we use the test data. We may need to shuffle that a bit, and to get a better result. And of course, we need to using that to get the performance. performance metrics. Okay, so basically, is the model good or not, or whether we need to change that altogether. We just scrap this model and choose another model to do the work. Okay, and yeah, I think that's basically 3 steps about machine learning steps. Okay.